Welcome back for more physiology. We're going to be dealing with the cardiac cycle in this particular lecture. In particular, summarizing the events into one diagram. It's a relatively simple lecture because it's describing this picture. So the way I build it, if I were to build it in class, is what you notice is, if you follow where the cursor is, we happen to have this lower black curve. And that turns out to be the atrial pressure. What we'll notice is it'll be low and then it'll pop up. The reason why it's going to pop up is we'll have atrial systole. It'll drop again. These little bumps labeled as C and V, that has to do with, blood flow and closing of valves and reverb and things like that. But the way I would draw it is you have flat line, we have a speed bump where it says A, that's for atrial systole. It's flat again until we have another atrial contraction or atrial systole, in which case we'll get another speed bump. Hooray. Our goal is to have blood go from atrium to ventricle, which means the ventricle, which is the red line, needs to be underneath that bottom black line. And that means blood will go from higher pressure, atrium, to lower pressure, ventricle. Got it. So blood goes from atrium to ventricle. As the atria contract and push blood into the ventricle, that's going to increase the pressure of the ventricle, which is why it also rises with atrial systole. At that point, the ventricle will contract by ventricular systole, and it's going to exceed that of the atrium, which is why the red line spikes all the way up. And when it goes up, it's going to cross the pressure of the atrium, and that's going to force a few things to happen. So the first thing that we're going to do is we're going to force the valve between the atrium and the ventricle. If this is the right side of the heart, that'll be the tricuspid. If this is the left side of the heart, that'll be the mitral valve, to close. That closing makes a sound, which is why down at the bottom you see a sound, S1, showing up, and that's because we hear a slamming of the door. The valve closes. And that also causes that little reverb that you see as C. The pressure is going to continue to increase until it reaches that of the artery, which is this top black line, the arterial pressure. It's going to exceed the pressure of the artery, and when it does so, it's going to actually force the valve between the the ventricle and the artery open, which will be the semilunar valve. If this is the right side of the heart, that'd be the pulmonic valve, left side of the heart, aortic valve. And it's going to keep going until it reaches about 120 millimeters of mercury, which means this is obviously the left side of the heart. The other clue that's the left side of the heart is they keep saying like LAP, the left atrial pressure, LVP, the left ventricular pressure, AP, aortic pressure. What you'll notice is the red line at the very top is higher than that of the black line, so blood is going from ventricle to artery. That's what we want. But as soon as the ventricle stops contracting, goes into diastole, it's going to immediately plummet underneath that of the artery, and that crossing point is going to trigger a heart sound. Here it has it being delayed a little bit, and there's a little bit of delay because of how close they are. But what you'll get is the second heart sound, which will be the closing of either the pulmonic or the aortic valve. The pressure is going to continue to drop with the ventricle until it drops below that of the atrium. So when ventricular pressure is underneath that of atrial pressure, what you'll get is the semilunar or the atrioventricular valve. So either the tricuspid or the mitral valve will then open up, and we're free to do this again. This top picture, even though I don't show C or V when I draw it, this top picture is fair game for you to be able to reproduce. And if you talk your way through it, you can actually replicate it relatively easily. This middle section here is dealing with the volumes. So what we end up getting is end diastolic volume versus end systolic volume, and that difference there is the stroke volume, but that's a different talk. The ECG, so the electrocardiogram, this is also something I would expect that you can replicate. So if you notice, with the atrial systole, bump A, it turns out to kind of sort of correlate with the P wave. So the two happen really similar to each other. With atrial diastole, when we get that little drop, and we have ventricular systole, that big spike, That turns out to correlate to the QRS complex, which is what we would expect because it's atrial diastole and ventricular systole. And when the ventricle starts to relax, ventricular diastole, that correlates with the T wave. So that also turns out to match with our pressure curve, as we would expect. What would I expect you to do? You should be able to draw the pressure curve, and you should also be able to correlate it with an ECG, meaning make the ECG match the pressure curve as closely as you can. The sounds aren't my big thing, so we don't need to worry about that as much.